Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Trigonometry series and concerns solving trigonometric equations. This guide describes how to solve trigonometric equations. Such equations may have more than one solution. A good way to find the solution is to draw a graph of the relevant trigonometric function. Introduction. This study guide concerns solving trigonometric equations such as the cosine of x equals 0.1. The study guide, Trigonometric Ratios, Sine, Cosine and Tangent, describes how to solve such equations by using the inverse cosine button on your calculator to find the angle x. X equals the inverse cosine of 0.1, which equals 84.36 degrees. However, this is not the whole answer. A trigonometric equation may have many solutions, and your calculator will only give you one. The answer the calculator gives might not even be the one you want. You will have to understand more about the graphs of trigonometric functions in order to solve these equations. In fact, the equation cos of x equals 0.1, where x can be any number, has infinitely many solutions. This is because trigonometric functions are not bijections and therefore do not have inverses. Which of the infinitely many x values would the inverse function give? See study guides Functions and Inverse Functions and Graphs for more on this. But there are inverse trigonometric functions which will solve trigonometric equations where the angle is restricted. It is important to realise that the values your calculator gives are not all the possible angles, but only a range of angles as described below. When solving sine of x equals a, the inverse sine of a is greater than or equal to minus 90 degrees and less than and equal to 90 degrees. When solving cos of x equals a, the inverse cosine of cos of a is greater than or equal to 0 degrees, but less than or equal to 180 degrees. When solving tan of x equals a, the inverse tan of a is greater than or equal to minus 90 degrees, but less than or equal to 90 degrees. Even though the inverse functions on your calculator only give answers in these ranges, some trigonometric equations will have solutions outside these ranges, and so you will have to take care in finding these solutions. Method for solving trigonometric equations. All trigonometric functions are periodic. They repeat themselves and give values for any value of x. Therefore, if you are given the value of a trigonometric equation such as cos of x equals 0.1, there are infinitely many angles x which satisfy it. Often a range of values known as an interval is specified for x, meaning you will be expected to find all the solutions which lie in this interval. In order to solve this equation, it is very helpful to sketch the graph of the trigonometric function you are interested in. Example: solve cos of x equals 0.1 for x greater than or equal to 0 degrees but less than or equal to 360 degrees. By taking inverse cosine of both sides of this equation, you get x equals the inverse cosine of 0.1, and a calculator gives this value as 84.36 degrees. Is this the only solution in the interval, x between 0 degrees and 360 degrees? The best way to find out is to draw the graph of the cosine function for this interval. The dotted line goes across at cos of x equals 0.1 and crosses the cosine graph at 2 points. The first one is near 90 degrees and is the one given by your calculator. So you can see that cos of 84.36 degrees equals 0.1. However, the dotted line also crosses the graph at another point near 270 degrees. This solution is not in the range that the calculator gives you, and so you have to work it out for yourself. By using the symmetry of the graph, you can see that the distance from this other point to 360 degrees is also 84.36 degrees. And so the other solution is 360 minus 84.36 degrees, which equals 275.64 degrees. You can check with your calculator that cosine of 275.64 degrees equals 0.1 as well. So the equation cos of x equals 0.1 has two solutions in the interval x between 0 degrees and 360 degrees, x equals 84.36 degrees, and x equals 275.64 degrees. In general, the method for solving trigonometric equations is as follows. 1. Sketch the graph of the trigonometric function you are interested in. 2. Draw a line across the graph at the value required. 3. You can now see how many solutions there are by the number of intersections. 4. Use the inverse trigonometric function on your calculator. 5. Check the graph to see if this is a solution. 6. Compute the other solutions from the graph's symmetry. 7. Check your answers by putting them into the original equation. The graphs of the trigonometric functions can be found in the fact sheet 5 basic functions. Example. Solve sine of x equals minus 0.866 for x greater than or equal to 0 and less than or equal to 360 degrees. 1. Sketch a simple sine graph including the values in the required interval x greater than or equal to 0 and less than or equal to 360 degrees, like this. Since the inverse sine function is defined from minus 90 degrees to 90 degrees, it is a good idea to include negative x values up to minus 90 degrees. 2. The dotted line is at minus 0.866 from the question. There are 3 intersections of the dotted line with the curve, but only 2 of them lie in the required interval, x greater than or equal to 0 degrees and less than or equal to 360 degrees, and so there are 2 solutions. 4. The calculator gives inverse sine of minus 0.866 equals minus 60 degrees. The range is given in degrees, and so you must make sure your calculator is set to degrees and not radians. 5. This value is negative, and so it is outside the required interval of x greater than or equal to 0 degrees, but less than or equal to 360 degrees. Reading across the graph, you can see that the first value in the range is more than 180 degrees. In fact, looking at the graph, it is 60 degrees more than 180 degrees, so it is 240 degrees. The second value in the range is 60 degrees less than 360 degrees, and so it is 300 degrees. So the values of sine x equals minus 0.866 for x greater than or equal to 0 and less than or equal to 360 degrees are 240 degrees and 300 degrees. 7. To check your answer, use a calculator to see that both sine 240 degrees equals minus 0.866 and sine 300 degrees equals minus 0.866. Sometimes the situation is more complicated. For example, when the variable is transformed from x to 2x, then other values may come into the given range. Example. Solve tan of 2x equals 4 for x greater than or equal to 0 degrees and x less than or equal to 180 degrees. 1. The graph of the tangent function is shown on the right. 2. The dotted line is at 4. 3. The dotted line crosses the graph in 2 places, but one of them is outside the range. X is greater than or equal to 0 degrees and less than and equal to 180 degrees. However, you will see that this value is still required. There are in fact 2 solutions. 4. The calculator gives inverse tan of 4 equals 76 degrees, so 2x equals the inverse tan of 4, which equals 76 degrees, and divided by 2, x equals 38 degrees. 5. This value is in the interval, and so this is one answer. 6. From the graph, the other value of tangent equal to 4 is 76 degrees more than 180 degrees, which is 256 degrees. This is outside the interval, but remember that the question involves 2x and not x. So in fact, 2x equals 256 degrees, which means that x equals 128 degrees, which is inside the interval. So the answers are x equals 38 degrees and x equals 128 degrees. 7. To check, use the calculator to see that both tan of 2 multiplied by 38 degrees equals 4 and tan of 2 multiplied by 128 degrees equals 4. You need to take extra care in examples like this, which involve a multiple such as 2x, to make sure you get all the solutions. Another situation that can arise is when the variable is offset, as in the next example. Example: solve cos of x plus pi equals minus root 2 divided by 2 for x greater than or equal to 0 and less than or equal to pi radians. 1. The cosine graph is shown on the right. 2. The dotted line is at minus root 2 divided by 2, which is approximately minus 0.7. It does not have to be accurate, as this is just a sketch. 3. The dotted line crosses the cosine graph in 2 places, but one of them is outside the range, x greater than 0 but less than or equal to pi radians. However, you will see that this value is also required. 4. The calculator gives inverse cosine of minus root 2 over 2 equals 3/4 of pi radians. The range is given in radians, and so you must make sure your calculator is set to radians and not degrees. Then you have x plus pi equals 3/4 of pi radians. And so, after subtracting pi, x equals minus 1/4 pi radians. 5. This value is outside the interval, and so it is not required. 6. From the graph, the other value of cosine, which equals minus root 2 over 2, is 3/4 pi radians less than 2 pi radians, and so it is 5/4 pi radians, which is outside the interval. However, x plus pi equals 5/4 pi radians, and so, after subtracting pi from each side, x equals 1/4 pi radians, which is inside the interval. As the question involves x plus pi and not just x, you must take extra care to make sure you get the correct solution of x equals 1/4 pi radians. 7. To check, use a calculator to see that the cosine of 1/4 pi plus pi equals minus root 2 over 2. Further guidance and information. If you have any further questions about trigonometry or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761 email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students' Office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students' Office at the University of East Anglia.